In this video, we're going to answer the question of what makes an answer proper. So it's really important that you understand the difference between a proper and improper answer, because in math, we want to make things proper whenever we need to. So first of all, the difference between improper and proper. The three answers on the left are improper. They're all potentially correct. Many of you got the correct answers on your tests or quizzes, but you didn't make them proper. Okay, here's why the following are not proper. This one is not proper because there's a square root in the bottom. Okay, it's not a proper fraction when there's a square root in the bottom of a larger fraction. Now this one is improper for a similar reason. It is improper because, once again, there's a denominator and it's inside of a radical. It's a little different looking than the previous one, but you cannot have a square root in the denominator of a radical. So the final one is improper because of the I. Remember, I is a square root, so this is the same as saying 8 minus 2 square roots of negative 1. This is a square root, it's in the denominator, it is not proper. So all three of these are improper because a denominator has a square root. The following over here are proper. Okay, maybe they're not simplified, maybe we could do more with that, but they are proper answers. None of them have a square root in the denominator. And we're going to talk about how to take the improper ones and make them look more proper in the next examples. So let's take a look at the process to make things proper. So the first one, this one's the most challenging to remember. But what you need to remember is your simple product of a minus b times a plus b equals a squared minus b squared. This is so important because what's nice is there's no a or b term. We have a simple sum here in the denominator, like an a plus b. If we want to make it so that we can square this square root of 3, so it's no longer a square root, if we times by something like this, it will magically make 2 squared terms. That's the trick, that is the special product you need to understand in order to solve this. So the trick is to multiply by the conjugate. You've seen that word recently in your vocab. So I'm going to multiply top and bottom by square root of 3 minus 1. This has nothing to do with the top. I know the top has the same exact factor, square root of 3 minus 1, but it is nothing to do with the top. It's everything to do with what makes the bottom disappear. It is not legal. This is really important. It is not legal just to go doo-doo-doo, gone, gone, the answer is negative 1 or something. You can't just cancel when there's a sum. The only way to simplify this is to take care of the denominator and make sure that you have no square root down there. So let's see what we get. We want to carefully FOIL. We know we're going to get square root of 3 squared minus 1 squared. Remember, your middle terms cancel. The outer term would be negative square root of 3. The inner term in FOIL would be positive square root of 3. They cancel. That's the whole goal. The square roots to not be there anymore. On the top, a little different. It's going to create a product, so I'm going to have all 4 terms in my FOIL. Let's take a look at what the top would give me. The top is going to give me square root of 3 squared. Well, that's nice. One less square root to deal with. And then I'm going to have minus square root of 3. Another minus square root of 3. And positive 1. So it looks like I'm going to get 3 minus 2 square roots of 3 plus 1 in the numerator. In the denominator, I'm going to get 3 minus 1. Continuing to simplify, I'm going to get 2 over 4 minus 2 square roots of 3. This is a proper answer. It's not simplified, but it is proper. So now when we talk about simplifying, I see that if I separate these, I can create simpler numbers. Okay? The way to simplify fractions is either to separate the addition and subtractions from the numerator or factor top and bottom. But I see that this will cancel to 2, these will cancel, and I'll get minus square root of 3. This is the correct solution for a simplified proper answer to the first example of an improper solution. Okay, let's take a look at the next one. The next one will also involve some simplifying. as well as making it proper. Okay, so the first thing that we want to do is make sure our fraction is as simple as possible, and it is 8 over 27 cannot be simplified. So at this point, we're going to separate square root of 8 over square root of 27. We all know that at this point, the trick is to times top and bottom by square roots. So I'm going to do that, and then I'll show you another way that can allow you to get rid of it, to make it even easier maybe for some of you. So this allows me, remember, to get rid of the 27 in the bottom. So this is a little bit easier to simplify and make proper. So we have square root of 8 times square root of 27 over 27. So that's great. The bottom is proper. The top, though, can be simplified and or multiplied out a little bit better. So I'm going to do 8 times 27. 8 times 27 is 216 over 27. This is a proper answer, but it may not be fully simplified. So here's the thing. Inside the 216, if there's any perfect squares, I want to take them out. Okay, so I check for things. I check for things like 16. Does 16 go into 216? That's a perfect square, and maybe it will. Does 4 go into it? Does 25? Does 9? So I check for all these things. So I'm going to check 216 divided by 4. I kind of knew it would be divisible by 4 because of that 8. 8 times 27 will allow me to have a product that has a 4 in it. So 4 times 54 is equal to 216. So I'm going to square root each of these individually, and the top simplifies to 2 square roots of 54. I double check the 54. Is there anything perfect to square that goes into 54? So once again, this is still over 27. 54 has a perfect square of 9 that goes into it, so I'm going to divide out the 9 and rewrite this as 2 square roots of 9 times square root of 6, all over 27. So once again, the 9 can change out to a 3, which was my whole goal. This is one big product, so I really have 6 on top, square roots of 6 over 27. One last simplification. The 6 and the 27 have a common 3 I can factor out. So I'm dividing top and bottom by 3, and I'm getting 2 square roots of 6 over 9. This is the fully simplified version of the product of this fraction right here. It became proper at this point. It became simplified completely here. So let's take a look at how we could have done this a little bit quicker, maybe quicker for some of you, but either way, you can do it in either direction that you've done before here. So one thing I could have seen at the beginning is that square root of 8 and square root of 27 had perfect squares in them to begin with. So I could have separated it right away and hopefully simplified. Square root of 9, square root of 3. So I see the 9 on the bottom and the 4 on the top right away. So this is going to create a 2 square root of 2 over, and the bottom will create 3 square root of 3. This allows me to just kind of get smaller numbers to deal with. 216 was kind of a big number to simplify. Top and bottom, I'm going to times by square root of 3 because I do not want that square root of 3 in the bottom. So I'm going to have 2 square root of 6, so I'm going to combine these two factors, over 3 from the original 3, and then this square root of 3 creates another 3. 3 times 3. Once again, my answer is 2 square roots of 6 over 9. Same solution, notice it's a lot less steps. So if you can pull something out of a square root, like we could out of these 2 square roots right away, it's going to help you simplify a little bit quicker. So pulling things out of the 8 and the 27, like we did here, can allow you to simplify a little bit quicker. But either way, you get to your end result by finding perfect squares to pull out of the square root. That is a proper simplifying strategy. So we're going to take a look at this last example with the eyes and how to simplify that. So let's take a look here at the one with the eyes. This one's similar to the first example that you saw here. I'm going to multiply by the conjugate. So I'm going to times top and bottom by 18 plus 2i. It has nothing to do with the top, so I'm only going to be multiplying by the conjugate of the bottom, because the bottom is what I'm worried about. Okay? Keeping in mind that when I do this, I want to properly FOIL, but on the bottom, simply going to be 18 squared minus 2I squared over the top, 24 times 18, 432, 24 times 2I, 48I, I times 18, 18I, and I times 2I, 2I squared. So it looks like I'm going to have, on the top, 432 plus, let's see, altogether I have 66 i's. And then, remember, this I squared turns into a negative 1, so it's really going to be a negative 2. So it looks like the top can simplify further. I'm just going to take care of that right now. 430 plus 66i. So the top is simple, but the bottom I want to simplify that. So 18 squared is 324, and then minus 2i squared, so it's going to be minus 4i squared. Remember, the I creates a negative 1, so this will be a negative 1 right here, the I squared. So it's really 324 plus 4, or 328. This is a proper answer. It's not written in standard form, which you've learned about with imaginary numbers. So if I wanted it in standard form, I'd have to separate it. 430 over 328 plus 66 over 328 with an I in front. This is a standard form, and I'm going to check using my calculator to try and simplify these fractions. This fraction will turn into 215 over 164. Looks like they had a common 2 in them, plus, let's see, 66 over 328. Turn that into fraction, and I get 33 over 164i. This is a standard form imaginary number. This was a proper answer. This is in standard form. So pay close attention to instructions and what you're being asked to do. Always make it proper, but putting things in standard form will require instructions being given to you. So bring it, ask me questions, and try this out. Here are some problems that you can try on your own to get some additional practice. So see if you can simplify the following. 2 minus square root of 3 over square root of 5 plus 1. Make that proper. Square root of 64 over 50. Make that one proper. And how about 8 minus I over 2I plus 1? And make that one proper. Okay, try those 3 problems, bring them in order to retake your test.